This is the Amp Hour Podcast. Released March 11th, 2025. Episode 690. Clap on, clap off, lights flicker.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
It's been a while.
Yes. Hello. Hey.
Hello.
What's new, man?
Is this the ASMR version? You're kind of whispering.
Chris is losing his voice. I was at a meetup on
yeah.
Monday. I had a meetup on Monday, and then I have little kids, so of course everyone's sick all the time, including me now. And so my voice is a little bit raspy. I remember thinking actually, oh, Dave used to always get sick so much, and it doesn't happen as much anymore. Oh yeah, your kids get bigger.
Yeah, exactly. Yeah, they're out of preschool and the daycare
exactly.
or whatever.
Mm-hmm.
Not daycare. We never sent them to daycare, but
yeah,
the preschooly thing.
Yep.
Germ factory. Congratulations.
Yeah, exactly. Yep.
And they just slobber everywhere, and it's like
they're adorable.
Yeah, I know. Nah, kind of past that. It's all good.
Yeah.
It's all good.
I did have I rebooted the meetup actually, and it's no longer on meetup.com because those so-and-sos, they doubled the price, man.
Did they? Yeah, because I quit that years ago. They were, I wasn't holding that many meetups, obviously, and I was paying this bloody monthly fee. What, they doubled again?
$90 every 6 months or something like that,
What?
and then they upped it to $190 or something.
Screw
it's
that.
just
You can organise it for free on the EEV blog forum. Screw that.
Exactly. Exactly. Yeah.
Nah.
We switched to Luma. I think I lost some people, unfortunately, but we had
Luma?
pretty good. Luma is a kind of an alternative platform. U.LMA. You'll see a bunch of links. I kind of always skip past them, and now that I use it, I'm like, oh, okay, yeah. But a lot of the hardware happy hours that our little collection of hardware happy hours around the country, the U.S. we use Luma, so it's okay.
Got it. Right.
Yeah.
Cool.
It's definitely they've updated it in the last 10 years, and they're not charging. Even if I think that they will charge for it at some point, but it's nice. It's actually nice. It's just, okay, yeah, this is things people should charge for. Okay, Yeah.
Got it. Yeah, that was just a rort. The meetup.com. Oh, God.
Yeah.
Yeah.
Good riddance. Good riddance.
Yep. Indeed. Let them die. Yep.
Well, they were part of WeWork.
Were they?
Yeah, they got bought by WeWork, and then they got spun back out, and then they got bought by private equity. And then the private equity thing, they jack up the price.
They got regurgitated.
Yeah. It's the same thing that happened to Evernote. You remember I used to love Evernote. I used to always talk about Evernote.
Yeah.
Same thing happened to Evernote. I didn't realize that's why it kind of went to crap. They jacked the price up. They stopped development on it basically, and then it's just fine. Private equity is trying to squeeze as much value out as it's the right to do that.
Yeah. But
I switched to a different one, and I use Joplin now, and a lot of people like Obsidian too. They're all note taking apps and.
Right.
It's great. So I'm taking notes in it right now for our show.
Excellent.
Joplin. Gotta tape that note in.
You know what else is going to crap?
What's that?
Alkaline batteries. I hate them. I've had multiple instances recently of products being almost ruined by my continually leaking alkaline batteries.
The product's ruined, or your version of the product's ruined?
My version of my actual meters here that I use, I'm dumb enough to leave alkalines in them, and
is there an alternative? I don't. You do a lot more with batteries than I do.
Well, there's
alkalines.
There's the lithium primaries. They're basically not going to leak, but they're expensive and they've got a higher terminal voltage. So potentially you've got to be careful about putting lithium primaries into some products. They may actually overvolt because some of the DC to DC converters that are obviously hooked up straight to the straight across the battery, basically, they might exceed their maximum operational input voltage if you hook them up to lithium primaries, which can get 1.75 volts per cell or something like that. So it's actually quite high.
So if you got a stack of 4, and
if you've got a stack of 4 brand newies, that can that can really add up. You can come a gutser. Yeah, because that's 7 volts, right? So if you've got 4, I think it's 1.75, they can absolutely fresh, open terminal, unloaded voltage, right? And that's 7 volts. So, and a lot of DC to DC converters designed for 5-volt operation, they might have 6.5 volts maximum or something like that, 6 volts maximum, that are actually designed to operate from alkaline cells. So, yeah, just be careful you don't come and guts of there. Anyway, so there's also, you can get the old school carbon zinc ones, right? But the carbon zincs, they can actually leak too, and they can potentially do more corrosion than the alkalines, but they're less likely to do it. But the alkalines are famous for it, of course. Especially
I've seen the effect. I've had the crusties in the back of the a meter or whatever. But what's actually causing that to happen? What actually
that's the alkaline fluid that leaks out, and then when you combine it with carbon dioxide in the atmosphere, it causes a terrible chemist, but it causes potassium carbonate crystals. God, I'm going to goof this off the top of my head. Okay. But yeah, they're the crystals that you see. So it combines with so it's not just, so that's when you get those little white crystals forming. That's basically extracted carbon dioxide from the atmosphere, and turns them into corrosive, horrible stuff. So that's why, to neutralize the alkaline material, you add an acid, white vinegar, to it. So that neutralizes out, because that's acidic, and that neutralizes the alkalinity. Is that a word? Alkalinity of the alkaline fluid that's leaking out, basically.
Wouldn't it be like basiness?
Yes, all that base stuff. Anyway, it sort of neutralizes it out, so that stops any further, rotting of your copper and your plated steel battery terminals and all that sort of jazz.
Got it.
But
but the actual leaking is just a mechanical, just
right,
liquid inside a container.
It's a physical venting thing. They are actually designed to leak. They are designed to vent the fluid out. If the internal pressure builds up too much, they've actually got a physical rubber vent on the end of them that will actually burst.
Like so temperature, vibration, that sort of stuff.
Temperature, humidity, pressure. A lot of people say that the battery, that when you put them in a hard spring battery terminal, that's actually putting pressure on the ends of the battery, and that can contribute to it. But there's no real hard evidence for that. But, everyone has their pet theory of why alkalines leak. And they leak more than what they used to. When I was a boy, alkalines never leaked, Duracells never leaked, and now they're called Duraleaks. That is their nickname in the industry, Duraleaks, because they just leak so often. It's ridiculous. But all the brands do it, Yeah.
Is there anything with the devices are just more efficient, so the batteries have to last longer because there's less current draw? Is there anything like
No, I think it's just cheapening down of the manufacturing process. Okay. Just a continual refinement, saving every last cent on the manufacturing process. Yeah, I'm sure that's the main contributor.
I could totally see that being the case.
Yeah. Anyway. Or you can put in rechargeable batteries, which they basically don't leak. They don't have a chemistry that really leaks, really. Yeah. So there's a whole bunch of people who will ban alkaline batteries from their lab and home and everything else, and they only use rechargeable batteries in everything, so they don't leak. So. And
we say rechargeable, you mean like rechargeable, like AA's and AAA's and
the
stuff like that?
The AA's and AAA rechargeables, the nickel metal hydrides. Yep. And they don't leak, really, essentially.
I had to do that I think they're nickel metal hydride. I actually have a battery pack right here. 1 second.
Hardly anyone uses the old school NiCad anymore. They're all pretty much the hydrides.
Here, let's see. I had to get a replacement pack for my kid's Tony box. You know what a Tony box is?
No, I got no idea.
It's like you buy these little, 10 centimeter tall tokens that are in the shape of an Elmo or Cookie Monster or Elsa from Frozen. And then it has NFC tag inside it. And then it reads the NFC tag, it goes out the internet, it gets songs, it downloads them to the thing.
Oh god.
Yeah.
Okay.
Yeah. And then it just plays music. It's just a music player.
Okay.
It's very cute. It is a brilliant branding play because literally I'm not selling you a record or a CD, which you can't really do these days anyways. Like, I'm selling you a tiny figurine for $20.
An experience. We're selling
I'm selling you an experience. That's right. Exactly. That's right. Yeah. And then the kids it's very durable. That is probably the most impressive thing. So yeah, this is nickel metal hydride. I just had to replace the batteries on it after a couple years. Right. But I got to open the box up, and the surprising thing in there is I can send you a photo actually. They were running an ESP32S3 in there. Not too surprising for a consumer good using Wi-Fi.
Right.
But the storage mechanism was a SD card that was like RTV'd to the board.
Nice.
Oh, okay. Well,
Yep.
that is a way to do it, I guess.
Well, you're even if you have to buy the socket for that damn thing, or even if you solder it.
Yeah.
I've seen the SD cards soldered directly to the boards. Actually reflowed directly to the boards because it's cheaper than buying the raw chip. You know, it's mad.
Yeah, there's just volume benefits from whoever's making the SD cards.
Exactly.
But
so it's just crazy. Or you get some surplus lot somewhere, of 1 million of these bloody micro SD cards or whatever. And then
I gotta. When this thing finally gives up the ghost, maybe I'll do it before then. But I could just take the RTV off. And I'd like to just see how they store the files, because this is also IP. So like I'm guessing they encrypt it. Maybe,
Oh, okay.
like they're downloading it, storing it on this
Could
SD
be,
card, but then, I could just take that out of there. Boom. I've got.
Is it going to be like in a FAT format, or I doubt it's like in a FAT format or something?
Yeah, that would probably be the easiest one if it's coming off an embedded device. But
just shove it straight in the PC and read it, but
Yeah, right.
Yeah.
Yeah. So
we decided to do that for the 121 GW meter, where that's just a FAT format, so it actually logs data to the SD card. And it's just a standard fat format.
Yeah, what do you got to hide, Ren?
Yeah. Well, exactly. But it means that you can physically, because the original concept was that you wouldn't actually physically take the SD card out. We would simply use the SD card as the storage, the flash storage medium. And then you would transfer the data via the Bluetooth. But then we realized that we had to rewrite. Then we realized that we had to actually add that to the boot code. It had to be in the ST processor. It had to be in the bootloader code to access all that, and it was just harder to do and didn't have space and everything. So we just went, let's just if you want the data off the SD card, you've got to physically take off the back cover, pull the SD card out, shove it in your PC. Unfortunately, that's just the way it went. That was just a design decision that we were sort of forced our hand on, really. Speaking of design decisions, I just released a video this morning, I'm sure you haven't seen it, about continuity testing on multimeters, latched versus unlatched. Because the BM786 meter, which I sell, when it originally first came out, it had a latched continuity tester. So it's a pulse stretcher, right?
Can you just define the two terms in this context?
Okay, a latched, an unlatched continuity tester is that it'll beep as soon as it gets a short on the probes, right? So under 40, 50 ohms or whatever, right? It'll just beep. But that means and if it's fast, it'll be sort of like infinitely fast. So it's sort of itchy
like
and
the
scratchy.
test you do when you put they can tap the two probes together. I see you doing it in videos, right?
Continuity tester, yes.
Yeah.
When you're troubleshooting your PCB and you're checking for shorts and stuff like that. So you put
I know what a continuity tester. I'm saying like when you're testing a meter, usually you're tapping the two probes together.
I
you're
am
seeing
tapping
how fast
the two,
it responds.
Yes, and how fast it responds. And if you just
Chopsticks.
lightly touch the probes, and especially if you don't have the gold-plated probes, right, then you've got to get a lot of surface contaminant on the probes, right? So they won't make. So if you only lightly touch them, you'll hear like an itchy and scratchy sound. It'll be like, I don't know. I can't do a buzzer, sound, but it'll pick up every little single break in that thing, so it'll sound all scratchy. If you just gently rub the probes together, and some people like that, but some people don't. Some people prefer that if the multimeter actually detects even a microsecond of low impedance, then what it does is it turns on the buzzer. And it pulse stretches that out. So even if it just detected 1 microsecond worth of short, it'll stretch it out so that you can hear it.
So like a
so
one
it's
shot
actually
kind of.
so that's called a latched continuity tester, but it's essentially a pulse stretcher, I guess you could call it. So it turns a short pulse into a longer pulse that you can hear and see if you've got one of those visual backlight things that turns on the LED backlight on the meter.
Does it have a timeout then too? So like
yes, it
there's
has
like a lower limit.
Yes,
and then it stretches too.
Yes, exactly.
And
A pulse
upper limit
stretches
as well.
it to 0.1 second or something like that.
Okay. I see.
Just so that it's audible. So that's basically the difference between latched and unlatched. Unlatched is just raw, works as fast as it can, but you'll get all this itchy and scratchy sound depending on your probe contacts. But on a latched version, you'll get a nice solid beep, and that will tell you. But one of the problems is, if you're probing a populated board, right, trying to troubleshoot it, check for shorts and stuff like that, the bypass capacitors and other capacitors on the board, what do they do as soon as you apply voltage to a capacitor? It's a short circuit, right? And that will give you a false beep. So usually when you're doing a troubleshooting a board, you're really doing it like quite fast, and you're like, just moving the meter over many different points, just trying to find, random shorts and things like that. And that can, and if you hear this solid latched beep, then then you waste time tracing that down, thinking that it's a real short when it's just a cap, charging up.
Right.
Yeah.
Right.
So it's a trade-off. Some people are fans of one version, some people are fans of the other version. And anyway,
some people don't think about this for a single second of their entire life.
Exactly.
Until they hear it on the amplifier.
Exactly. Because most people, you just make you make your choice of your multimeter, you buy it, and you just learn to live with whatever, however
idiosyncrasies
it works.
and
Yeah, exactly. So anyway, but Ryman decided they wanted to sort of like standardize on this across different models of multimeters. So they changed it in one of the firmware updates to the meter. They actually changed it from latched to not latched. And some people are going, great, and other people are going, oh, no, I want my money back. So and then just like in the 121 multimeter I talked about, we couldn't add that feature because we ran out of ROM space, essentially boot space. They said, well, why don't we make it user selectable? And they went, oh, we can't. We don't have enough firmware space available to put in both features, unfortunately, to make it, you hold down a button when you power it on and you can change the mode from latched to unlatched, which would be really cool, but unfortunately. And so there you go. Oh, by the way, there is a third mode of operation, which I think the 121 GW multimeter might be the only one that does it on the market. Maybe, don't quote me on that. There might be one other.
Chaos monkey mode, and it beeps all the time.
It's a third mode, which is a beep on open. So what you do, which is great, if you've got, say, a cable that you think there's an intermittent break in the cable, what you can do is hook up your meter in this beep on open mode on the 121 GW. So it just beeps all the time, and then so when you move your cable, right? You twist your cable and you do whatever, and if there's any intermittent break in there, then it will beep.
I see.
So it's kind of like the inverse of
it's like you're passing current through the cable and you're trying to see where the current.
Yes.
It's really like a current flow check.
It's a current flow check. Yeah,
it's like a continuity.
Yep.
Yeah,
totally.
Continuity test. Yeah.
It's an inverse continuity test. So that's just another way to do it. So
that's a good idea. Yeah.
Anyway, so so there's fanboys of both versions out there, and they're now down. I haven't read the comments in the last hour, but I think they're just battling it out in the comments. Yeah.
If you're gonna find people that do care about it, they're probably on the EV blog forum.
They're on the EV
discussing
blog forum.
it.
Yes, exactly.
Yeah.
Yep.
Boy,
Well,
they really care.
that's how it came up. Actually, somebody actually complained on the forum that why does it do this? And anyway, I won't get into the whole thing about the threshold levels either. Under how many ohms?
Right. That's another point. But that usually is settable on the. Not always, but
on the 121 GW, you can choose between 300 ohms or 30 ohms. On almost every other meter on the market, you can't. You just live with any value that they happen to set, which could be 30 ohms, could be 50, 100, 200.
Handheld, you're saying?
Yes, handheld.
My bench meter it's settable.
Oh, is it? Okay, cool.
Yeah.
Yep.
Keithley 2000
right.
settable.
Ah, yes.
Yeah.
Yep. But
all right. Got a little test equipment. Got a little consumer goods and batteries. What else we got?
I don't know.
I've got stuff. I got a new. Speaking of design decisions, I am currently in the throes of laying out the tightest board for me ever.
I've seen this.
Not
you showed
the
it
tightest.
to me before the show.
Yeah, for other people, but this is I'm making an AirTag clone So
Is this for work? Is it?
it is for work. Yeah.
So it's like a demo product, is it?
That's right. Exactly.
Right.
Yep.
Okay.
Yeah.
And I presume it's going to be open.
It is. Yeah.
Right,
Exactly.
cool.
Yeah.
Excellent.
I think there's probably other people who've done this sort of thing too, but I was kind of interested in being a challenge for myself and,
Right.
being in control of the open source IP and all that usual stuff. And, putting the sensors I want on there. Have you looked inside I know we talked about an AirTag when
I've
they
never
came out
looked
a little
inside an
bit.
AirTag, no.
Yeah. I was re-looking at Colin O'Flynn, past guest of the show. He actually had a bunch of not reverse engineering, but it was just like doing teardowns and probing when they first came out. And so I was looking at his stuff and some of the other, teardowns and things like it. And it's pretty, it's a complex little board for sure. It's definitely more complex.
I didn't think there was much in it. I thought
There's
it
two
was just
PCBs in there. There's
Really?
two PCBs. Yeah.
So
And it's
how does it
because-
work actually? I thought it just regularly transmitted, just burst transmitted its location or something.
It is. It does have a beacon mode, but and that is the primary Find My type of thing. So usually it's in beacon mode. I'm not sure if it's a true beacon or if it's just doing the pairing. I'm not good at Bluetooth. I hopefully will be sometime. But there's like different modes. People who do Bluetooth think I'm an idiot right now, but there's like a true beacon where it's just, hey, the temperature's 23. It's just like regularly putting that out, and then there's listeners that might be, basically it's like open. Excuse me. But then there's also advertising.
I'm staring at the PCB now. Oh yeah, it's a
Got
little complex ring-based beep.
Yeah. Yep.
Yeah.
Yep.
Same
And,
as yours, really. Yep.
Well, no, so the reason that theirs is different is so they have two PCBs. They have a speaker. They have a true speaker in there with Class D.
Why is there a speaker? Why does it need
So
to
that
be?
you can, so like a lot of these asset track, like these little Bluetooth asset trackers, they do it so that if, you can tell where your keys are, your keys can transmit. But what if you want to find your keys, right? That's the
Right.
hard part. So
Got it.
now your phone can then beep
Okay.
your stuff, and then they have to be loud enough to hear them.
Dude, when I was a boy, all you had to do was whistle, and your keys would beep at you. Are you aware
I would like to
of
come
this
back to that.
marvelous
I would like to
technology?
I would like to come back to that, please. That
Okay,
sounds
let's
awesome.
come back to this technology. I'll try and find it while you're talking
Okay.
about the AirTag. Okay.
Yeah. So another thing, the AirTag specifically, and like this is one of many, right? So like AirTag is out there. There's the Samsung one. Tile was out for a long time as well, whatever. AirTag also has ultra wideband, which is how if people have an iPhone, you can basically then within 10 meters, it starts to actually do ranging and stuff like that. So it'll start to, it sets up a compass. So it'll say, oh, you're within 10 meters. It's listening for the ultra wideband signals and doing signaling back and forth with your iPhone, that sort of thing. And so there's just much more complex stuff in there. It's also a user replaceable battery. So it's got the battery holder is built into the plastic case, which is very fancy mechanically. So it's a little bit thicker. So anyways, what I'm doing is instead I'm taking a CR2032 with welded tabs on there. And I guess I'll have to paint a little picture. So that's the 20 in 2032 is a 20 millimeter diameter battery, and I'm matching the size of the outer diameter of a AirTag, but just for my PCB, so it'll definitely be bigger when there's a case around it. So I'm doing a 32 millimeter PCB. So I basically have 6 round millimeters to work with for all the stuff that I want to put on this board. And it is, and Dave's seen it, it is not a small amount of things. It is, it's a bit extra, I think is the term the kiddos use these days. It, much
Is
like
it single-sided load or I only saw the top
it's
side?
single-sided as well.
Right,
Yeah, that's
I thought it
another.
was. Right, yeah. Do you
it's a
think
choice.
about double-sided load?
I had thought about it, and I'm challenging myself not to. Mostly just to keep the bottom side flat for if it's in a case. I don't want to have like standoff and stuff like that. I want to just have it so it can truly sit flat. But another reason is because I'm using NRF52840, which is an older version of the chip, but kind of it's still available and it's still all I need really. There's the new 54 that's out, which is like lower power, and I'll switch to that eventually if this goes anywhere. Right. But it's got NFC as well, so you can basically have an NFC antenna. And so I'll share with Dave just so we have a shared context, but we'll try and describe it here. So there's a 24 millimeter soldered down NFC antenna on the bottom of this thing too. And then just to list all the
and that goes over the
are,
battery. Does that?
It goes. So the battery is flush with the bottom of the PCB.
Yeah.
So if I get rid of this, so the battery is flush with the bottom of the PCB.
All right.
There's two pads on the bottom that actually you solder the antenna down to, and then there's a ferrite core so that it basically blocks the RF energy from getting absorbed into the batteries.
Oh, I was going to
down
ask
the
that.
battery.
Yeah, if you're putting it directly on the bottom of the battery, doesn't that absolutely
It's
kill the
gonna
range?
soak up all the delicious RF. The 13.56
Whereas it
megahertz.
looks like in the AirTag, they've got the coil outside of the battery in the middle, I think. That's what it looks like.
That's right.
So,
Yep.
right. So
Yeah,
you're putting it directly over the back of the battery.
That's right. Yeah.
So it only transmits in one direction, really. It's very
yes, that's right. There's two
poor
SKUs.
efficiency.
There's one that goes up and one that goes down.
Oh, you got two different SKU. And people who don't know, if we're talking about SKU, we're not talking about clock SKU. We're talking about stock keeping
SKU.
Unit.
There you go.
SKU,
Yeah.
stock keeping unit for your store. So you basically make two different versions. One transmits in one direction, one transmits in the other. Oh, dude.
Yeah, I know.
Come on, that's the ultimate. That's the ultimate cop out.
What? Why is that a cop out?
Well, you want one product that transmits in all directions, Seriously?
Me? No, it would go into the battery then, Dave. I want to go down.
Yeah, but then you get another, I don't know, etch the antenna into your board or something so that it's not covered by the battery or something like that. I don't know.
Okay, yeah. I mean, this is a Rev A, man. This is a Rev A, so maybe.
Right.
Yeah.
And there are two little buttons on the side, are they? It's got little...
it's got a reset. It's got a
tactile
boot,
buttons,
user button, that sort of thing.
Right.
It's got a buzzer. It's got a magnetic detection, like a magnetic read switch. It's got a security module. It's got a weather sensor. It's got an IMU. It's got a microphone. It's got
it's funny that the
chip.
largest component on the board is the programming header.
It's a programming header. Yeah, it's a Tag Connect 10. Yeah. My
God.
coworker Mike actually found out that there's a serial port you can get on the edge of a 20-pin J-Link, so we're using that too, which is interesting. I never knew about that. Yeah. Oh, and there's LEDs, or there's 12 LEDs around the edge as well to do like a little clock.
What you could have done if you didn't want to dedicate PCB layout space to the programming header, what you could do is you could have castellated edges on the edge of your board with the pins. And then you can just press that against the edges, and the edge of the board becomes the programming header. So it takes up no physical space on the board. So
yeah, it's not bad, except then you have to make your own kind of interface jig.
Oh yeah, but you only have
so
to make that once, right? You've got to only make the one interface cable for it, and then
Oh
Bob's
yeah,
your
well,
uncle.
unless I'm making it for a bunch of people that I know, so. That's the key thing.
You can provide a free programming cable with every thing.
Cable,
Instead of
true.
two different SKUs, you can provide a free programming
That's
cable.
not bad.
Yeah.
Could maybe do a flat side too. Like I do a little notch cutout to make the alignment happen, but maybe I could do that with a. Yeah.
Yep.
Yeah, it's not bad. That's not bad.
Anyway, that's just a little technique for small boards like this. If you've got absolutely no room. When your largest component is your programming header, then wow,
right.
Yep.
Yeah. So this is the first time I've done a 0.4 millimeter BGA before.
Yeah, 0.4 millimeter pitch. I called it as soon as I saw it. I went, that's probably 0.4 millimeters.
It's a stinker.
Yeah.
Yeah, and it's got a
Are they making much smaller these days? Can you get a point?
Yeah, you get
I'm
0.25.
sure you can. 0.25. Oh God.
Yeah, it's.
I'm sure they're used in the latest Apple shoe phones, right, and stuff.
Oh, they're small. I mean, they're basically going silicon down on the board these days.
Yeah,
it's
right.
Nuts, Yeah, this is nothing compared to what some people do. Yeah, I just chatted again with Lucas Henkel, past guest of the show, who does the amazing animations on LinkedIn and stuff like that, and just like the scale that he's at for those modules he put. Oh my God, it's so out of my scope, but
totally.
I was partially inspired by his stuff. So it's I wanted to try out some smaller things, but this looks massive compared to some of the things that he's doing, which is pretty interesting.
So have you built one of these yet?
No, this board is still in development. Yep. Yeah.
And you decide, it's interesting, I noted straight away that you decided to go with a battery that has welded tabs onto it. That actually just solders straight onto the board. So it's not sort of like user replaceable. You do need the specialized battery. It's not like a battery holder.
That's right, yep.
So
right, exactly. And so if you compare it to like the AirTag, right? AirTag is definitely designed to be replaceable over time. This is, you would need a soldering iron to get.
Is it? I thought the AirTag was like the Apple AirTag was like a sealed thing.
The inside is sealed, but then the
Right.
battery compartment is not.
Oh,
so,
is it? Oh,
yeah.
interesting. Didn't
Yeah,
know
no,
that.
it's
Okay.
nice
Yeah, I have
engineering,
no
for
idea
sure.
about these Apple gadgets. Yeah.
Yeah. There's actually just a hack that just happened too, using the Find My network. Someone just sent it to me en route, something like that. Let me see if we can find it. Yeah, so the Find My network is basically like all the phones are out there that like opt into it, which I think they do by default. They pass along these messages, right? They get a I think encrypted packet from the devices, and then they kind of hand it along to the network, and then you say, hey, I lost my keys. Has anyone seen, ABC 1 2 3 4 5 6 7 8 9 10, whatever the ID is, and then the network kind of forwards it along to you, and you could say, oh yeah, it was last seen, at the library or something like that, based on the GPS location. So it's like all these devices working together. But yeah, the enroutetag.github.io. We'll put this in the show notes. This is some hack that's happening, right? Some exploit that just got reported. So there's a paper that just went out. So that's enjoy your
Cool
security
bananas.
vulnerability, Apple people. That doesn't happen often.
They'll be Johnny they'll be straight
Yeah.
on that, I'm sure. Yep.
Yeah. As far as impressed as I think I told you I got a Mac Mini, like a Mac Mini M4.
Yes, you got the Mac
Yeah.
Mini. You were trying to sell me on it. No, you had a look at it, but I don't know. There's just no
it's
real.
great. It's really
Oh
nice.
yeah,
It's
if I had
for
that,
the cost.
if I had that need, oh yeah, I've been hearing amazing
yeah,
things.
yeah, it's really
Yeah,
nice.
it's just for the price. Except if you want to buy extra memory, I did actually watch a lot of Highness just did a video on it. He just did a video on should you buy an Apple, because he's not an Apple person, and they tried to sell him on the Apple Mini or something. But and then he went through the cost of it, and they wanted to cost this outrageous price for an extra 8 gig of memory or something. So that's
Yeah.
Oh,
on the memory side,
Yeah,
exactly.
Yeah,
yes.
on the
because you
expansion
can
side.
upgrade the storage. Like Jeff
Yes.
Geerling has stuff about storage. You can, that's
Yes, he
usually
does.
replaceable effectively. But yeah,
But
it is,
they just charged an absolute
they really get you.
shocking
Yeah.
amount for you know, to go from 16 to 24 gigs or something.
Yeah, there's
So
like
it was
there's
like-
YouTube Shorts and like TikToks. You can see where people are just replacing the PGAs themselves.
Oh,
which
really?
Is like, oh, it's so impressive. Oh my god! and then
that's
they
mad.
they show it working.
Yeah.
But yeah,
Wow.
yeah.
That's thoroughly impressive. I'm amazed that people have the guts to do that. It scares the shit out of me.
Yeah, same. Same.
It still to this day, changing a BGA would scare the shit out of me.
Yep.
It's just not something that I've ever been comfortable doing. Yeah.
I mean, so I will say, like, the hardware, both the Mac Mini, the AirTag, all these things, like, the hardware is undeniably, like, just gorgeous. So well done. Obviously, at scale, too. That's amazing. I have been so underwhelmed with all, like, cloud things from Apple. Everything, the software is really nice, too. Like, the Mac OS stuff, great, fine, whatever. Every time I use their cloud stuff, it's just, oh, God. It's like they just forgot to hire people. I'm sure
Really?
there are tons of
Is that
people doing it.
bad?
It's just...
Why is it that bad?
I think it's me, honestly. I think it's so different from how I normally operate, and the people that are in like the Apple ecosystem are so used to it. But I think it is horrendous. As an example, I was trying to help my mother get some photos off of her iPad when I was at home at my parents' home during Christmas, and it's just the experience is so one note, like single way of operating, that like there is no flexibility in there. It's just, well, you have to do it the Apple way, and if you don't, then you got to go to a Genius Bar. And so,
Yeah, right.
okay, well,
Genius bar in quote
I am
marks.
very capable to do things, and there's literally nothing else to click. There's no tutorial. There's nothing you can do. It's just like, all right, well, just what they really want you to do is throw your iPad out and get a new one, which
Right, yes.
my mother
Yeah, of
should
course.
do. But
Yeah.
yeah,
Yep. No,
yeah, and yeah, new hardware would
boy.
be amazing. Yeah.
Unbelievable.
Actually, that is an interesting thing. Okay, so last Apple thing, and then I want to get back to my hardware, of course. It is interesting. Their new iPhone came out. I'm sure you didn't see it. It's the
Ugh.
new iPhone 16.
I know some people bitched about
E.
it not having some charger
Yeah.
thing or something.
Yeah,
Whatever.
all these people are upset about it, whatever. But the interesting thing is the modem. So this is the first time Apple bought part of Intel's modem group, and they're not using Qualcomm silicon anymore. And so that is really interesting to me.
Right.
I think that is going to be, that's the big deal, right? I mean, I work with
Right.
modems a bit, and they are kind of just a wacky space to be in. There's not a lot of players. There's not a lot. There's like a kind of a consortium of IP ownership, my coworker just wrote a great article about like how wacky modems are that I can link into, and just the fact like a new modem person, like a new group coming into the modem space is interesting on its own. The fact that it's Apple is even more interesting.
Wow,
and the fact that they're getting like really crazy like power efficiencies that other phones aren't getting, that's the jam. Like that's so Marquez did Marquez Brownlee, who does MKBHD, does the reviews, and he mentions it, and he gave it a little bit of airtime. But I mean, he's a tech reviewer, so he had to talk about all the stuff that's missing. Fine, great video, like always. Marquez is amazing. But I think the Intel, the Apple like modem silicon, the amount of stuff they probably had to do to get that like up and going and working, and like with all the carrier certifications, all that crap, like that's gonna be a much bigger article when future stuff comes out, and I'm really interested to see where all that goes, because it's not like there's just there's no startups that are going into the modem space. It's just
is this potentially related to the satellite to phone direct service stuff? Because you talk about a crazy energy efficiencies and all that sort of stuff. That's kind of needed for the satellite to phone direct service, because everyone's talking about that at the moment. They'll be out this year, or if they're not out, or trial units are out or something. And Apple was one of the players.
There is some early stuff that's out there. Yeah, for sure.
I think they've already announced it here in Australia. Our telco partnered with Starlink and Apple, I think, to have straight. But it isn't like you can stream and make calls, but you can send text. So you can use it as like a text modemy thing. Yeah. So
I think that's like the NT. So like non-terrestrial networks, NTN is like part of 3GPP version 17, I think, is when that started. That's like the governing board. Right. Most modems aren't at that level yet. So like any modem that I use, I don't think I've used any modem past like version 14. Like any of the IoT modems that are out there, they're all like 14. Maybe they're starting to edge their way up there. So, but obviously the handset stuff always kind of leads the pack anyways. So they are definitely getting that stuff, and it's definitely coming down the line. Like you said, Telstra,
right.
I'm guessing that was...
Yes.
Yeah. Telstra has a T-Mo just partnered with Starlink too, and there's other providers other than Starlink that are doing this NTN type stuff.
Yep.
I think we're gonna have a couple of years of people being like, they said there's satellite and now there's not, and I'm so pissed, and I deserve this. Okay, well, but it is so cool. I mean, it's basically, remember me talking about like that book, Eccentric Orbits, like the one about the Iridium satellites that were Motorola started.
Yeah. Right.
This is what they thought it all was going to be. This is the vision. Like 40 or 50 years later.
This was the future. Yeah.
This is the vision, but like it took so much additional space junk and so much like processing power and just lower noise amplifiers on the front end of these phones, and but it is possible, which is still mind blowing to me. I mean, like I can't get the vision of like all the bad guys on their satellite phones. Like they always have the antenna that like has to fold out and then it like extends 4 feet.
Yeah.
Yeah. So,
oh boy.
I do think there's a lot of interesting stuff coming. Don't get me wrong.
Yeah. Cool.
Yeah. So but I'm not making any of that stuff.
Right. So you wanted to know about the key finders. These that you whistle at. You weren't aware of this back in probably 80s, early, definitely into the 90s. All the rage was when you would this little key fob thing that you attach it to your keychain, and you would whistle. You would whistle, and then it'd beep back at you. It would actually.
How precise would your whistle have to be? Like, is it like?
I can't remember offhand.
Did you know anyone who had one?
Yes, I think I may. Yeah, I think I may have at one point.
Yeah, this feels like some like vintage YouTube type stuff. That would be great.
I have sent you a link.
Okay,
there is a Wikipedia page. Doesn't give, but I'm sure these were around in the 80s. And you would have to whistle. It was very temperamental. Or other ones you would actually clap. So you'd give 2 claps like that, and like your keychain would beep. It would beep back at you. And one of the things you would do back in the day is you would just walk around a shopping centre or something and you would whistle or clap and to see if anyone's keychain responded. Yeah. So there's a photo of a typical one there. There's a couple of little coin cells there powering it and a little LED to light up and flash, and there's a little chip on board thing on the PCB, and that's it, and a piezo buzzer, and I guess.
Yeah, what else
I'm not sure of the tech that went into it. There's just like a filter in there so the piezo transducer would be picking up the sound and also emitting it at the same time after it picked it up or something. Yeah, I don't know. But yeah, they got a long battery life. They had a couple of years at least battery life, I think.
See, that's interesting to me because how is it? It must have some kind of thresholding circuit that
it has a thresholding circuit with a filter, with a bandpass filter, and you had to whistle at a certain frequency, So I'm not sure of the exact parameters of that, but these were all the rage back in the day, all the rage. Oh man, didn't you? And table lamps that would give the clap.
Oh,
and
I knew
would
that.
Turn
Okay,
your
come on, clap
side
on.
lamp on. Okay, right.
Clap off.
Right.
Clap on, clap off.
And they would do the same for the keychains as well, I think. But I don't think they were as popular because they would false trigger, all the time. Whereas the whistle had to be, a specific, and it had to be a specific bandwidth for a specific period of time at a specific amplitude, and then it would, Anyway, cool. Yeah.
Speaking of filters, I learned I'd seen this part name before, but I never knew what it was. I never bothered to look, but I found a SAW filter. In a schematic I was looking at.
Surface acoustic wave, for those who don't know.
Yeah. This is at 2.4 gigahertz, and it's basically it is what you were talking about. It's a bandpass filter.
Yeah, it's
just
a
in this case,
it's a physical.
very high RF.
Yep.
Yeah. Huh.
No,
Have you used them in designs and stuff before?
Yes. Yeah. SAW filters, you could buy them in a little ceramic package or something.
Yeah, that's what this was.
Yeah. Like that. Yeah. Okay. Yep.
Yeah. In this case, I think it was just for interference and probably passing FCC testing because it was RF. But yeah, I've never used one because usually I'm just doing single band type of things.
Yeah, but they're So basically, for those who don't know how they work, I believe it's like a piezo substrate, and then you would have a transmitting element and a receiving element on them, and then it would physically transmit inside the chip itself. But then it would, and the physical dimensions of the little transducer elements in there would determine the frequency of the filter. So it was.
Oh yeah, it says it's a direct analog implementation of an FIR filter. Oh, that's really interesting.
Oh, really? Okay.
Delayed.
Yeah,
that's really interesting.
Really. Yeah.
Wow.
Okay.
Yeah. So it's like how you have like buckets in an FIR filter, like when you're doing it digitally. Right. It's doing the same thing and just basically like passing the waves along.
The waves physically crystals. Pass along the ceramic. Yeah. I think they're a piezo ceramic substrate.
Yeah, you're right. Yeah, that's right.
Yeah.
It says it's electromechanical. Right. I'm reading Wikipedia, of course.
Oh, okay. Where is it?
Yeah, cool. I mean, RF's a new field for me still.
You're right, yeah. No,
many years later. And I'm not even
I assume people still use them, SAW filters. I haven't looked at that for years.
I mean, like literally I was looking on a board. That's where I found it.
Oh,
what
okay,
the hell is that
right.
thing? Yeah, no, this was on a Thingy 91. Okay. I was looking at had a similar, it has the 52840 on it. So I was like, oh, look at that. Is it in this one? No, maybe it was in this one. It was in front of, it was like a little black blob in front of the antenna. I'm like, what is that thing? And Nordic releases the schematics, which is great. Actually, all the files. So nice.
Actually, they're probably still used in phones. I wouldn't be surprised if they're not still used in phones. Maybe I don't know.
Yeah.
And again,
I mean, if you know your band and you're not relying on like the harmonics, you probably don't want the harmonics. So.
Right.
It's amazing anything works. Honestly, this is
Yeah, that's a bit of it's really physics magic. That sort of stuff is like kind of really cool. It's materials physics magic.
Right.
Yeah.
Just put these little crystals in place and
yeah.
We should go we should go to one of those conventions where they're like selling, like energy crystals.
Oh, right. Yeah.
And we should walk around to the tables and be like, do you sell SAW filters? I hear that these have resonance that will heal me, but I really need resonance that will help me heal my spectrum. Can you help me heal my spectrum?
Right. Oh God, I've got a photo of one of those guys at one of those stands at Byron Bay, I think it was, which is like a hippie town here.
Oh, yeah,
and they
yeah.
have the markets, and you can
A
imagine.
lot of pot
Oh
smoking
my
out
God.
there.
Oh yeah.
It's all the surfers.
And and there's this guy that runs this hippie crystal healing stand. Oh my God, and he's got all these posters up along the front about you're being blasted with all this 5G energy and shit like that.
Right, and that guy,
his
he would
little
really
pyramids.
benefit from a saw filter, right? Just
Yeah, I know.
keep it out, man. Maybe tinfoil hats are like
God.
the new saw filter.
Yep.
Should have been
Yeah.
wearing piezoelectric hats. That's what they really should have been doing.
I'll see if I can find the photo of that for the thumbnail. But
I think we've talked about him before because I remember
I'm sure
generating
we have.
art about the crystal vendor
Yep.
on Midjourney a while back. So
Right. Yep. I'm sure we
Yeah.
have. Yeah, but it's cool. Oh boy. Anyway.
Yeah.
What have we got on our list? A fond farewell to Unmanaged 615. Thank you very much. Thanks for all the fish he's had to check out of Reddit for reasons I won't go into. But yeah, thank you very much for putting in all the effort over the years
Yeah, it
to
was nice.
give us links and everything. Yep.
Yeah. Thank you.
And,
Thank you, Unmanaged. We've spoken highly about you here, and we'll think fondly about your links and your
I've
help
got
with
he
that. We
sent in a
appreciate it.
mailbag thing once. I've got a currently
okay.
so it's over on my
Nice.
shelf over there is an Unmanaged 615 magnet thing. You can see it. It's right under my speaker there.
Nice.
Yes. Anyway, I put something on here
Whoa. What do you
from
got?
the EV blog forum. I just saw
Bustling
this
thing.
last night, but I think it's been going for a thread which has been going for a week. Anyway,
I
a
did see this,
newbie
actually.
asked retired engineers, how did you learn using oscilloscopes in the 1980s without the internet?
Yeah.
It's actually a good question.
It is a good question.
One
One
that I've answered.
I have no idea about because I was neither using the oscilloscope in the 80s, nor did I really exist much without the internet. I did exist without the internet, but not in the
Yes.
electronics context.
Right. Yes, because like videos did not exist, the internet did not exist. You could not watch demonstrations of people using oscilloscopes. So how did you learn how to use oscilloscopes? Well, I've actually semi-answered this in my video how I became the EEV blog guy. A talk I gave at the University in New South Wales.
That talk was about 15 years ago, just FYI.
No, it wasn't. It was about 2 years ago.
Yeah, it was pretty close to the beginning of the show. I mean, you've been talking about it for a long time.
No, dude. I'm sorry. No.
You gave some talk about, okay, all right.
No,
fine,
no,
you find
that's
it.
another.
Maybe it was a
no.
different
That is a
university
different
talk you gave.
That is a different.
Oh,
no,
okay.
this is
all
no.
right. Sorry.
EV
looking
blog.
it up.
I've got to look it
I
up
could
now.
tell.
It is now. I only put the video up 6 months ago, but it was a year ago. It was only a year ago I gave this talk at the
okay. Must have
university.
been different
in New South
university or
Wales.
something. Okay.
Yeah.
All right.
I will share the link with you. There it is there. Anyway, I actually show a photo of my bedroom because I got out the old film, I got out the old photos and I scanned them in. I found an old photo of my bedroom and there at the end of my bed are bookshelves. Oh my God. And these bookshelves are full of books and magazines and things that
the
you
real
would
answer.
read.
I think that's the real answer. Yeah, the magazine piece.
Right? Is that and you would, and back then the manuals were great, right? So when you bought your oscilloscope, when I bought my first oscilloscope, yes, there was no internet, right? It was in the 1980s, and you buy your analog oscilloscope. Mine was a 20 megahertz dual channel COS 5020 jobby, and it was very nice. And it came with a beautiful ring bound manual, and the manuals were great. They would show you, what each control did and how the waveforms are supposed to look and stuff like that. The manuals were really good back then. So you would read you would RTFM, literally. Or you would read articles in the various magazines of how to use your oscilloscope and stuff like that. If you didn't have anyone to show you, if you didn't go to school, that actually had a lab with somebody to show you how to use it. If you had to learn it on your own, then that's how you learned it. And yeah. Read.
I think there's also
people.
probably there's a self-selecting, like there weren't as many oscilloscopes to be had, right? It was just a smaller market, I think.
Oh yes, and they're all and they all work pretty much the same. They're all dual channel 20 megahertz analog. Well, if you're able to afford it, you might be able to get a 60 megahertz version. Maybe.
Right.
With a dual time base was killer. I'm telling you. Delayed time base, delayed sweep, dual time base was the duck's guts. That changed everything. That allowed you to effectively zoom into a waveform. this is in the pre-digital age, right? These are on analog scopes. So you get your analog waveform and you go, oh, I think I can see something in there. Can I zoom in on it? You bet you can. You use your second time base to actually select a faster sweep speed, and then you would have a delayed sweep thing, which would then, on your second channel waveform, you would get a zoomed in version of the waveform that you're actually looking at. It was great.
Yeah.
Do you have any idea what I'm talking about?
I
Do you
don't.
ever
I'm
use
sorry.
a dual time-based analog oscilloscope?
I have used it. I've used, I think, just a single channel on my old scope.
Right.
On a
Yeah. Nah.
Tech 400.
It's not the same. It's not the same.
Yeah.
And then you had the delayed sweep. So if you had like a trigger point, of course, right, because there was no storage, right? So if you had like a long period waveform that lasted like a second or something, for example, but you triggered, way over at the start on some trigger event, right? You set up your trigger, so you're triggering over here, but you really wanted to zoom in and see the waveform at zoomed in on a further part of your waveform. How do you do that? Well, you use the delayed time base, which would delay, so it'd trigger, and then it would delay the sweep. So that's why it's called delayed sweep. So it wouldn't start sweeping across your screen until that delay period that you actually dialed in to the front. So then effectively, you could choose a longer time base, and you could effectively zoom in to a part of the waveform that was much further down after the trigger event. And that was magical, all these little tricks to, because we didn't have storage back then. Of course, of course you could get analog storage, but they were like, if you could afford an analog storage scope, you were rich, right? Or you're some big lab, to afford an analog storage scope. But yeah, so we had to wait until digital scopes came out before we could single shot capture stuff. And then that just changed everything, being able to single shot capture. There was no more dual time base stuff.
Yep. Yeah.
Although I think there is one, maybe two oscilloscopes on the market, that's digital oscilloscopes, modern ones, that actually have a dual time base on them. But don't ask me to, maybe it's a Uni-T one or something. Don't ask me to give you the exact brand or model, because I can't. Yeah. But I think it might still be a thing, because technically there are some people out there who still worship the dual time base to independent time bases and have independent triggering systems. That's the trick, right? Is that, in theory, because a digital oscilloscope, you only have the one trigger event, and then you've got to rely on having a big enough capture memory to then be able to capture everything you want, and then to be able to zoom in on a point, right? But I think there's at least one model oscilloscope out there that has two independent triggering and time-based circuitries in there, so that you can trigger it, so you can have effectively a delayed trigger kind of thing, like we could get old school analog. Anyway, there you go.
Yeah. I was thinking back to like when I was learning after, like you said, after all the digital storage came out, but like triggering for me was always like a tough learning curve. Like I just, for some reason, I feel like it wasn't just explained to me, or I couldn't grok it. I don't know. And I feel like that if you were forced to like even see a signal, you wouldn't see anything until you figured that out. That might be a good thing to pull forward.
Totally.
Actually.
And free running, and modes, and normal mode, and all that sort of stuff. Yep. I think have I ever done a video on triggering oscilloscope? I've done a video number 159, oscilloscope trigger hold off tutorial. There you go. And then I've done advanced oscilloscope triggering, episode 1583. Oh, that's pretty recent. Glitch pulse run interval testing triggering. Jeez, I don't remember doing that one. Man.
Glitch run. That sounds like I remember there was a bunch of scopes that were talking about runts when they're like hard to capture, right? But I remember there was a bunch that were doing that as like we can even capture that. They were doing some kind of intelligence that was like, it triggered, but it's like less, it's some kind of binning, I think, outside of the trigger level. So they were able to capture runt signals.
Anyway, that was not a popular video. 26,000 views.
No one knows what a runt is. You got to explain what
advanced oscilloscope triggering. No one wanted to know about advanced oscilloscope triggering.
Most people want to know.
Then I've done a whiteboard video on what is oscilloscope AC trigger coupling. AC trigger coupling is a different thing. So I've done a whiteboard tutorial on that.
Well, actually, I have one other thing I want to talk to you about before speaking of AC stuff. So I'm thinking about holding off on calling an electrician, but I've got lights flickering in my house, and I'm wondering what I should think about doing at that point. I think what it is.
Are they old school compact fluorescents?
Oh, hell no. God,
Right.
no. These are all LEDs. It's and it's like the whole kitchen will flicker. We have a washing machine on the second floor, and there's a sub panel up there, and I'm pretty sure it's like the inductive load. So it definitely happens with the inductive load, like when the washing machine is like it's driving the drum basically, and you can hear it upstairs. It's like spinning it around, and you can see the lights flicker. In conjunction with it, okay, well that one, it's not good, but it's at least understood, right? I'm like, okay, that.
Yeah.
And then there's other times though where it's just, I think it might be, so we have a garage, we have a air conditioner out in our garage basically, and that's like a long distance from our main panel, and I think that might be kicking on. I don't hear it obviously kicking on, but then I think the flicker might be like the long inductance of the cabling going out there. I'm just like, oh, what the heck? It's just most of the time I'm just pissed. I'm just like,
are they
so
different brands of LED lights? Are they different brands, or is all the same brand? Because if they're all different brands, that makes it more puzzling. Because if they're because then it must be the mains dip in or something like that.
That's what exactly.
Right. Oh, well, we probe it.
That's what I'm thinking about. Yeah. I mean,
have you got a differential probe that you can safely probe with?
No, I don't know.
Or you're going to have to go old school and remove the earth. Yeah.
Yeah. I have 100. So I have a 100X probe, and I have.
Oh no. Okay.
I got some cheapy handheld scopes, and that's probably what I'll do.
Usually, you can use like a battery powered scope.
I think that's probably
probably
the way I'll do it. Or I can use my Analog Discovery 3 and just plug it into a laptop and not ground that. What do you think about that, Dave? Is that a good idea?
No, I don't recommend that at all.
Yeah, but it's not grounded. There you go. No ground.
As long as you don't connect it to the charger, yeah.
Yeah,
and
exactly.
even if the charger's isolated, it's still AC coupled due to the Y-class safety caps in the charger.
Oh yeah.
Trap for young players.
Yeah.
I mean, so
if you can't pick it up and physically separate it from everything around it, probably shouldn't be, plug it into the wall. Yeah.
Although, that's the only thing I can think of is that the mains is physically dipping. You're getting a brownout. Right? You're getting brownouts on that sucker.
Yeah.
And that's dodgy as. Yep.
Yeah.
But you should be able to see that. You should be able to see it.
So just wait for a flicker to happen and just watch the mains and see if it like flattens out the tops or something like that.
Something like that. Because those LED lights, they're just like, they're not using some
regulated,
weird
right?
earthing system or something. They're just straight across the active and neutral, and they've got a full wave bridge rectifier in them. And so it must be a serious dip.
Relative recency bias, but remember I had all the electrical problems at my old house.
Oh yeah,
So like,
that's right. This is your new house. Yeah,
it's a new house. I'm in a brand new house, man. Yeah, and it's about the same era.
You're
it's
a
not
bad
like these
luck
are old
charm,
houses.
aren't you?
Yeah. Me and electricity don't get along. Yeah, the only thing I'm thinking about, I think one of the easy checks, relatively low cost, would be like just to switch all the breakers out. Like there's like just corrosion on the breakers, stuff like that. Like I could just do that, but I just want to like actually know what's wrong. So I think the probing.
Yep. Yeah, the first thing I do is probe it just to see that it is a brownout, because I can't think of any other way it's going to do that on a simple LED light and a whole bunch of different brands at that. It's got to be browning out. Damn.
Yeah. And I should definitely do that. I'm still looking at solar, so I got to figure this out before solar.
Oh, right, of course. Yeah. Damn. Well,
damn.
Good luck.
Yeah, indeed. Yeah. Power, electricity. Who needs it, right?
Yeah, I know. Pesky electricity. Let's go back to the. Yeah.
The scale difference is kind of wild sometimes. I also live like relatively close to a substation, so like the scale difference from like here to there. First off, it's great living near a substation because our power run to the substation is very short. There's not a ton of like trees and stuff in between, so like our power has not gone out yet. Knock on wood. But like the scale there, obviously, it's very very obvious. It's 375 kilovolts going down to whatever the local delivery is, and then
How do you get public maps for that? Can you get public maps to see which Does anyone in the electrical industry know? Because I would like to know where my house is actually, what substation my house is hooked up to. I wonder if there's a map.
That's an interesting question. Yeah, it does feel like something that like should be, it's like a public utility.
Yeah,
like you think it'd be, but it's also kind of
like
Homeland Security.
Like, right.
Yeah.
Yeah, you don't want people sabotaging a substation because they know it's going to take out this area, you know. And all my power is underground, so I can't even just go around and walk around and follow the cables, you know.
Right.
Yeah.
Yeah.
Anyway.
Yeah, but just like the scale difference then. So like substation, then obviously my house, you know, I get 120, 240 on the two-phase, but then, you know, now I'm staring, I still have the board up on my screen and just nanoamps, picoamps, just that scale difference. It's so wild.
I know. It's massive. Yeah.
Yeah.
Yeah, like I'm staring at instruments right now. I can go from picoamps, and in fact, I can go from femtoamps. I can generate femtoamps up to, you know, hundreds of amps, like just in a bunch of instruments that I've got. The scale is massive.
Yeah.
It's crazy.
Yeah, we're just touching on the middle easy range, right?
Yeah, right. Yeah. I have done that video, Enter the World of Atto Amps, which looks into an electrometer. Yeah, crazy stuff. Like when you're literally counting electrons, you know. So, yeah, it's nuts. I've also done that video where how many electrons does it take to light up a LED? I've actually done that video. I think it's like a couple of hundred. I think it's a couple of hundred electrons are required to light up a LED to any visible level. So anyway, yeah, fascinating stuff when you start getting down there. Yep. Oh boy, or right up there in the big scale. Anyway, good luck with that.
Thanks, man. Yeah.
Yep.
We'll see how it goes. Hopefully this summer I'll have some solar stuff to talk about. We'll see.
Excellent. Sounds good. All right. Catch you next time.
See you.